Section 5.4 is on dividing polynomials. You can divide polynomials using long division, and it's very similar to doing long division with whole numbers. Let's take a look at an example. We need to use long division to find the quantity 5x squared plus 2x plus 3 divided by the quantity x plus 1. So to start with, we're going to write it very similar to the way we would write a division problem with regular numbers. So I'm going to do x plus 1, and that goes into 5x squared plus 2x plus 3. Okay. Now, one thing you'll notice is that with a polynomial, we don't have place value. We don't have a ones column, a tens column, a hundreds column, and so on. But we do want to keep track of columns. Like here, we will have an x squared column, an x column, and a no x column. So just keep that in mind as we're placing values up top there. So also, as we do with long division, I'm only going to focus on the beginning of each of these terms. So I'm going to focus first of all just on this x of the x plus 1 and just with the 5x squared. So what do I have to multiply x times to get 5x squared? The other way of saying that is, what is 5x squared divided by x? And that would be 5x. So I put it up here, make sure I keep it in the x column. Now I take the number up here, the term that I put up here, and multiply it by the whole term out front. So 5x times the quantity x plus 1 gives me 5x squared plus 5x. And as with long division, I would subtract. So my 5x squareds cancel out, and that leaves me with a negative 3x, and bring down that 3. Now again, negative 3x divided by just the x out here gives me a negative 3. Multiply that negative 3 by the whole binomial, gives me negative 3x minus 3. And I want to subtract, and that's going to leave me with a remainder of 6. To write my final answer, I take the binomial that I have on top, or whatever the polynomial is on top, plus, because this is a positive 6, 6 over what I was dividing by. And that would be my solution. Here is a chart, a little table from your textbook that explains actually what's going on here. To be honest, I think you'll easily get lost in all of their notation. Let's just do another example and see what that looks like, doing long division. So here, we can also use this to determine if a binomial is a factor of a polynomial. In other words, in this case, does x squared minus 2 go evenly into the polynomial x to the 4th minus x squared minus 2? Is there no remainder? If so, then x squared minus 2 is going to be a factor. So let's go ahead and do that. So I'll do x squared minus 2, and that goes into x to the 4th. Now you'll notice that I don't have any x to the 3rd term or an x to the 1 term. So I'm going to put those in with zeros in front. I can add a 0x to the 3rd to this polynomial and not change the value of it. Minus x squared plus, I don't have an x, so I need a 0x minus 2. Anytime you're doing long division with polynomials, we need to make sure that we have like a placeholder for each power of x. So x to the 4th divided by x squared is x squared, and notice I'm putting it in the x squared column. Now multiply that x squared by the binomial out front, x to the 4th minus 2x squared. Well, I guess I didn't actually need the x to the 3rd, but it's a good practice to do. Subtracting, my x to the 4th cancel out. Negative x squared minus a negative 2x squared gives me an x squared. Bring down the 0x and bring down the negative 2. X squared, this x squared divided by that x squared is a positive 1. Put it in that column, and that's going to give me an x squared minus 2. So I guess I didn't need the 0x either. Subtracting those, I'm left with a remainder of 0. So yes, so since there is no remainder, x squared minus 2 is a factor of my polynomial. So my polynomial p of x is actually equal to x squared minus 2 times x squared plus 1. A simpler method of doing long division is called synthetic division. It uses just the coefficients of the polynomial and then the constant term of the binomial. Let me show you how this works. So one important thing to remember is this, what we're dividing by is in the form x minus a. So in this case, my a is going to be equal to 1. Okay, that's the number that I'm going to use when I divide. So I'm going to put a 1 over here, not a negative 1, a positive 1, inside a little box like that. And then I'm going to pull off the coefficients from my polynomial and just write those. So 4, negative 3, 2, and another negative 3. Now I'm going to leave a line right here blank because I'm going to fill in some numbers there and draw a line down here. My first step is to bring down whatever my first coefficient was, so bring down a 4. Now here's the kind of the tricky part. You take the number in the box, multiply it by the number down here, and put it up there. So it's kind of like a backwards check mark. 1 times 4 is 4. Goes right there. Now, different from long division, I'm going to add these. That gives me 1. Do it again. This 1 times that 1 is 1, and it goes there. Add these, gives me a 3. This 1 times 3, put it here, gives me a 3, and that gives me a 0. Generally what we do is draw a line between the second to the last and the last number. This is my remainder, which is really cool. And then I need to write my solution. So what I need to do here is add my x's in. So these are my coefficients, but what is my highest power of x? Well, looking back here, I had an x to the third that I was dividing by an x, so that means my solution, my answer is going to have an x squared. So this 4 is the coefficient of x squared, and then I just go down. Plus 1x plus 3. Oops, sorry about that. And this is my solution. I really like synthetic division. It's nice and easy. Here's an example, word problem. The polynomial x cubed plus 9x squared plus 23x plus 15 expresses the volume in cubic inches of a box whose length is the binomial x plus 5 inches. What are the other two dimensions of the box? And you'll recall that the volume of a box is length times width times height. So we have one dimension, the length, which is x plus 5. I need to figure out what are the other two dimensions. So I'm going to take my polynomial and divide it by my binomial x plus 5. Now remember, this is in the form x minus a, so that means in this case my a, or the number in the box, is going to be a negative 5. So negative 5 goes out here. Pull off your coefficients, 1, 9, 23, and 15. Leave a space, draw a line, bring down your first coefficient, and now multiply. Negative 5 times 1 is negative 5. Add those. Negative 5 times 4 is negative 20. Add those. Negative 5 times 3 is negative 15. Add those. And remember, your last number is the remainder, which is really cool. I didn't want to have a remainder here. So now I need to add my x's back in. Since I was taking an x to the third and dividing it by an x, my answer is going to start with an x squared. Coefficient of that is 1 plus 4x plus 3. Now, that is actually the product of the other two dimensions. So they gave me the length, so this is the width times the height. So I need to factor that, break that down. And actually that's going to factor into an x plus 3 and an x plus 1. So the other two dimensions of this box are the terms x plus 3 and x plus 1. And the last thing we're going to take a look at here is the remainder theorem. It gives us a quick way to find the remainder of a polynomial division problem. It also allows us to evaluate the function at a particular value without using substitution. So let's take a look at this example. So given that p of x is x to the fourth plus 3x squared plus 9x, let me do that again. X to the fourth plus 6x cubed plus 9x squared plus 3x minus 3. What is p of 4? In other words, what is the function value when I put 4 into here for x? Well, I could do that by substitution, but that would be really tedious. I can actually do this using synthetic division. So I'm going to take this 4 here, put that in the little box out here, pull off my coefficients. So 1, 6, 9, 3, and -3 and do synthetic division, and what's going to happen is my remainder is going to give me the value for p of 4. So let's bring down our 1. 4 times 1 is 4. Adding gives me 10. 4 times 10 is 40. Adding gives me 49. 4 times 49 is 196. Adding gives me 199. And 4 times 199 is 796, and that's going to be my remainder. Subtracting 3 from that gives me 793. So this is my remainder right here. So that means that p of 4, if I were to plug 4 into this polynomial, it would be equal to 793. So that's a really cool way to evaluate a function at a particular value. So in this section, we took a look at polynomial division using long division and synthetic division to both divide polynomials, but also to find the value of a function at a particular point.